Welcome everyone to ENG 461 and EMG 421, Systems and Controls. In this video, we're going to look at a brief introduction and talk about some motivation as to why we want to study control systems. And in later videos, we're going to come back and kind of elaborate on a couple points and give some examples of what we're actually talking about. So let's start by defining a control system. So a control system, as defined in a textbook, is subsystems and processes which are assembled for the purpose of obtaining a desired output with desired performance given a specified input. So I've sort of highlighted our three key areas there. So we're talking about something that is doing something, so we have some output, and of course we have some specifications that we want that output to fall within. And again, we'll look at some specific examples in later videos to help make this more clear. And this output is occurring for a specified input. So a common representation that we're going to use, and we'll come back and we'll talk about this a lot more in later chapters, is block diagrams. So sort of the most simple case here is if we just sort of include our whole control system in this one block. So what we're saying then is we have some input over here on the left, which I'm calling x of t. It goes into our control system, which is making sure we get our desired output, which I've labeled over here on the right as y of t. And again, even in the next few videos, we're going to sort of define these things a little more clearly. And then in the following chapters throughout the semester, we're going to get a much better idea about how all of these things interact. So typically, we're going to be building control systems for four primary reasons. So the first reason is power amplification. And so as an example of this, we could think about a large antenna. So maybe this is a large directional antenna that we want to point in a certain direction to transmit radio waves or television waves, or maybe it's even a telescope that we're using to pick up signals from outer space. But at any rate, we're talking about a large antenna, and if we want to move the direction of this antenna to where it's pointing, we don't necessarily want to be doing that manually with a gear train or doing it by hand or anything like that, but rather we want to be controlling that with just a small knob. So of course, if we're able to control that with a small knob, there's going to be some electronics involved. There's going to be some elaborate control system that's allowing us to control the position of this antenna without having to sort of exert an excessive amount of force or effort. Our second reason that we want to build control systems is remote control. And so this might be the one that most people are familiar with because there's heavy overlap with remote control in the area of robotics. So robotics is a very big area in control systems. Sort of an obvious reason that we would want to have remote control would be hazardous environments. So this could be anything from a factory floor where we have maybe a lot of heavy equipment that could easily damage or easily hurt somebody who's not paying attention. So we could have a robotic arm, for instance, in there doing assembly. Another example would be maybe in environments where there are high levels of radiation and it's not safe for a person to work. The third primary reason that we deal with control systems is convenience of our input form. Convenience of our input form. And so an example of this would just be our simple temperature control system in a house or a building. So with our temperature control system, if you think back to an older thermostat, of course you might remember that there was sort of a dial that you would manually move. So in that case, our position of the needle would be controlling our temperature. But of course, in newer models, everything's digital, so you could just put in a numerical value, which is going to set whatever temperature you want in your house or in your building. So of course, that's a lot more convenient than having to sort of find some way to input a temperature to get a desired output temperature. So that's one way that control systems are very useful. So our fourth primary reason we want to build control system is compensation for disturbances. So compensation for disturbances. And so as we're going to see in a later video, not all control systems are capable of this. There's only a certain type that are, and we'll talk about that a little bit later. But for now, let's sort of link this idea back to a couple of our previous examples. So if we talk about our large antenna from our first primary reason up here, let's say there's a large gust of wind that causes the antenna to move out of the desired position. Well, we would want our control system to be able to compensate for that. So first of all, it has to recognize that, and then to move the antenna back to the desired position. We could also talk about our temperature control system. So maybe we have a window open in a house, and let's say it's really cold outside. So if we're heating the house and we have a open window letting cold air in, our thermostat should be able to detect that and adjust accordingly. So these are examples of compensating for disturbances. And again, we'll come back and we'll talk about that in a little more detail later on. So you can kind of tell by looking at these four primary reasons, one really cool thing about control systems engineering is that it has the ability to span across a lot of different disciplines, engineering disciplines, disciplines in the sciences, even other disciplines as well. For instance, control systems are also found in nature, so they're not necessarily all man-made. So also found in nature. So the example that is brought up in the textbook is a pancreas. And so basically what our pancreas is doing is it's regulating the blood sugar, and so we can model that as a control system. We could also use models for non-physical things, and we can model these as control systems. So can model non-physical systems using our control system theory. So of course non-physical, I'm talking about things that aren't tangible, we can't necessarily touch them. But for instance, we could talk about student performance. So as an input, maybe we could have number of hours available for studying, and output would be desired grade. So of course, if you study more, you would expect your desired grade to be higher. We could also talk about some disturbances coming in. Maybe I throw an extra unit in there, and if you don't account for the disturbance, then maybe your grade is not going to be what you expected based on your study time. So again, it's not necessarily limited to just systems we're building, but these control systems are also relevant to nature and for modeling non-physical systems as well. So that's it for our brief introduction. So I know a lot of that is still pretty vague, so hopefully in the following videos, we'll be able to kind of nail down some of these ideas and get a better sense of what we're actually talking about.